The next section we're going to cover is section 4.2 on solving systems of linear equations by substitution. So in the last section we talked about solving systems of linear equations by graphing. But if you do that, you have to check a lot of points, and it's often a lot easier to solve the systems using algebra. So we're going to go through a process that will let you solve these equations without graphing. The first step in solving by substitution is to solve one of the equations for one of the variables. In this class, you'll typically be working with two equations with two variables. So I like the look of this equation. It looks like it would be really easy to solve it for x or y. So I'm going to take that equation here, and I'm going to solve for y. I could have just as easily solved for x, but I had to pick one of them. So now what I'm going to do is I'm going to take this equation and substitute. And it's very important, now you're going to use the other equation. So I'm going to take y equals negative x plus 5, and I'm going to substitute that in for y in this equation. So I'm just going to, where that y was, I'm going to put some parentheses and put that expression in there. And now I'm going to need some more room to solve this. So we have 2x minus x plus 5 equals 1. So if I distribute that negative 1 through, that's going to be plus x minus 5. And then when I solve for x, I am going to get x equals 2. So now, I'm going to take that value for x and it doesn't matter what equation I substitute it into, because either one should give me the same y. So I can take this equation up here, 2x minus y equals 1, and if I put in 2 for x, I'm going to get 4 minus y equals 1. Subtract the 4 to the other side and get negative y equals negative 3. So y equals 3. Now the fourth and final step is to check. So I will check it by substituting the value I have for x and the value I have for y. Go ahead and rewrite those over here. X equals 2, y equals 3. I'm going to take those and substitute them in for x and y in both equations. So I'll take the first one and see what happens when I plug in those values for x and y. So that's going to be 4 minus 3 equals 1, and that's true. So now I'm going to take the second equation. X was 3, X was 2, Y was 3. So we get 5 equals 5. So that's also true. So the solution of the system is 2, 3. Now that we've gone over the general steps, I'm going to go over some of the concepts from the last video in the context of substitution, which is determining whether a system is consistent or inconsistent, dependent or independent. So I'm going to do the same steps as last time. I'm going to solve for one of the variables. So I always just look for what's easiest, and in this equation I see that I have an x right here. So it looks like it would be very easy to solve for x. All I have to do is subtract 3y to the other side. So now I'm going to take this equation here and I'm going to substitute it in to the second equation. So I'm going to be substituting for x because I have x equals this expression. So where the x is in this equation, I am sticking in this entire expression on the other side of the equal sign. So I'll distribute the 3 through. That's going to be negative 9 plus 30. Then if I add the like terms, that's negative 12y plus 30 equals negative 6. So I'll take this over here. Negative 12y is going to equal negative 36. Divide by negative 12, get y equals 3. So now I can take this expression for y, which is a number, and plug it into either equation. It doesn't really matter which one. So I'm going to take the first equation again. X plus 3y equals 10. And I am going to put the parentheses where the y was and substitute in the 3. So x plus 9 equals 10. So x must equal 1. So then it looks like our solution is going to be 1, 3, because we had 1 for x and 3 for y. But we have to check it. So this first equation, I'm going to put in a 1 for x. I'll go ahead and write the equation up there actually. X plus 3y equals 10. So I'm going to put in 1 for x and 3 for y. So 1 plus 9 equals 10. It's true. And the second equation, so 3 times 1 minus 3 times 3 should equal negative 6. So that's 3 minus 9. and that is also true. So 1, 3 is the solution. So we know this is a case where we have one and only one solution. So since there's a solution, the system is consistent. And since there was a solution, we also know that they had to be different lines, because the same lines are never going to have a solution. So it is independent. Now we're just going to go over how you'll know when you've ran into those other two cases where you either have no solutions or infinite solutions. And these are cases that you've probably already run into when solving equations. It's just never been with two equations before. So here is my system. And I already have one equation that's solved for y, so I'm going to skip that first step because I've already done it for myself. But I'm going to substitute this expression in for y here. So I'm going to take that 2x minus y equals 4 and put this expression for y right here. I get 2x minus 2x, and then negative 1 times negative 4, positive 4. So these are going to subtract out to 0, so I'm just going to be left with 4 equals 4. So this is true, but I didn't find any values for x and y, and the reason for this is because no matter what the values are, I can find a solution because these are the same line, and you can see that if I did a little bit of algebra on this one. If I subtracted that 2x. You would see that those are the same line. And when we had two equations that actually represent the same line, that was called a set of dependent equations. And so you'll know you've run into this when you're doing substitution if you get a true solution here with just numbers. And I'm not talking about when you go through and check it, because you are supposed to get this when you're checking the other ones. But when you're substituting something in, substituting an expression in terms of another variable, and you run into an equality that holds true like this, that's an indication that you got infinite solutions, which you've seen before. So now, if you don't have a solution to a system, when you're solving through, eventually you're going to run into some kind of nonsensical statement. So I'm going to take a set of parallel lines and try doing substitution. So I'm going to solve this first equation for x because it looks really easy. I can subtract 3y from both sides and get x equals negative 3y. And then I'm going to substitute that expression in to this equation. So I have x plus 3y equals 6. So I'm going to substitute this in for x. And then what do I get when I add a negative 3y plus a positive 3y? That is always going to be 0. So I just got 0 equals 6. That's not true. So if you are solving through and you run into something that is clearly not true, then you have no solutions, and it's an inconsistent system. And that concludes section 4.2.